Question number 2, which one will have the largest elevation in boiling point, that is the delta TP? Option 1, that is A, 180 gram of glucose in 1 kg of water. B, 342 gram of sucrose in 1000 gram of water. C, 18 gram of glucose in 1000 gram of water. And D, 65 gram of urea in 1 kg of water. Now, let's start with the solution. Now, one thing that we need to know is all of these are being taken in the exact amount of water, and that is 1 kg of water is taken into consideration. Now, when they are taken 1 kg of water, now we need to find out how many moles are being utilized. So therefore, here we'll utilize the delta TB is equal to Kb into M. M stands for the molality, right? So Kb is the constant. And what we have is M. M is nothing more than the molality, right? So in all the options, we have 1 kg of water that has been taken into consideration. So therefore, it's quite natural that Kb remains constant for all of these because water is a solvent that is used. Now, can we say that delta TB, okay, directly depends upon the molality now. So in the molality, again, the solvent remains constant. That means it depends upon the number of moles. Okay, so therefore, if we observe this particular cases, we need to find the number of moles precisely. So let's observe the option A. So in the option A, the number of moles, how much do we have? The number of moles is 180 gram has been utilized in glucose. Now, glucose has a molecular mass of 180.56. So we'll directly approximately take it as a 180 grams, right, per mole. So therefore, the number of moles over here is 1. That is 1 mole of glucose has been utilized, right? So this is nothing more than the value of N number of moles. So let's keep this one aside. Now, let's go with the second one. So that is an option B. Now, sucrose has been utilized. So number of moles of sucrose. So the amount added is 342, and the molar mass of this particular sucrose is 342 again. Okay, so molar weight of sucrose is again 342. Okay, so again 342, again what we have is N is equal to 1. So the number of moles that have been utilized is again 1. So again, delta TB remains same for both of these particular cases. Let's observe the C. Now in C, 18 grams of glucose has been utilized. Now, number of moles is equal to 18 grams. We are adding molecular weight is 180. So therefore it is going to give me as a 0.1 mole has been utilized. That is nothing more than a value of N here, right? So let's keep this one aside. And finally, we will go with the last one, that is the option D. So option D, 65 grams of urea. So number of moles of urea. Now, molecular weight is equal to, it's 60. Okay, 60 grams. So 60 grams per mole. Now, here, how much they are using? 65. So therefore, 65 grams is been added. Molecular weight is 60. So naturally, it is going to have 1.083. So therefore, number of moles is a slightly greater when we compare to the rest of them. So therefore, our answer is the option D, as the number of moles are greater. The delta TB is going to be greater for 65 grams of urea in 1 kg of water. Thank you.